All right, so I'm just going to draw a little sketch here. We got Sandra going north, directly north for a while at a constant velocity of 10 meters per second. But then she sees this big rock in front of her, dangerous one, put some spikes on it. She doesn't want to hit that rock, so she's going to accelerate herself. Now, the acceleration, she's got thrusters, so she's able to accelerate herself on this frictionless surface. The acceleration is to the east. Okay, so this is her acceleration. What's going to happen? She'll accelerate for a little bit, and that may change her direction a little bit. And then she'll accelerate a little more, and then a little more, a little more. So she's actually going to end up going in some kind of a curved pathway and avoiding this rock. Her gradual acceleration is going to make her curve a little bit. And you've actually seen shapes like this before. It's actually the same situation as just gravity pulling down on an object. Just we kind of rotated it a bit, so now it's Sandra going on a frictionless surface, but there's still a constant acceleration in one direction. It's going to cause the object to curve in the shape of a parabola. But that's just some interesting details. Don't really need to know that to answer the question, but I thought I'd point it out. To do the actual question, it's really pretty algebraic. It's using a big 5 formula and just calculating the missing variable. So I'm going to start making a list of givens here. So the V1, her starting velocity is 10 meters per second north. And then her acceleration is 0.40 meters per second squared east. And she's accelerating for a time of 5 seconds. And it's asking us to find her new velocity after firing her thrusters. So what is V2? So I can actually just use the formula for the definition of acceleration and rearrange it for V2. So acceleration is the change of velocity, V2 minus V1, divided by time. I'll isolate that for V2. So I'm going to start by multiplying time to both sides, so acceleration times time, and then plus V1. So I think I prefer, just going to rewrite it like this. Okay, so that's algebra steps. I'm not writing every single rearranging step, but that's what I come up with. I prefer doing V1 plus the next term, because then it's kind of like you take your starting velocity and then you're adding however much you're changing the velocity by. I just like to think of it that way. So filling in the numbers and the units and direction here. So I haven't been doing that before. I'm doing that more now just because the directions are in 2 dimensions. So that's the only way I know how to think of it at this point. So I'll write 10 meters per second north. That's the starting velocity, plus this is going to be a change of velocity, acceleration times time. So it's going to be 0.40 meters per second squared east times the time of 5.0 seconds. So when we write out the units here, I'm just going to take this one extra step. What is meters per second squared times seconds. Well, one of the seconds would cancel out, leaving us with meters per second. I was talking about the second term there. So this will be 10 meters per second north. Here, I'm going to multiply those two numbers together, 0.4 times 5.0, giving me 2.0. But the units are going to be meters per second. Okay, so that's what I was saying before. Meters per second squared in seconds. So the seconds is going to cancel out with one of the seconds from that seconds squared, leaving us with meters per second. And the direction is preserved as east. So really, I'm doing 10 north plus 2 east. And that's not equal to 12 because they're not in the same direction. They're in perpendicular directions, so I'm going to be drawing a right angled triangle. This can be 10 north. This can be 2 east. And what I have to find out is the resultant of that. So that, which I will label as V2. That's what I'm trying to find out here. I'm going to need to know the angle as well, so I'll label that theta. So that's Pythagorean theorem in inverse tangent again. So the magnitude will be the square root of a squared plus b squared, which is, well, that's going to be pretty much 10. Like, it's the square root of 104, which is going to be pretty close to 10. 10.2. So when I round it to 2 sig figs, it's actually just going to round to 10. And however, that's not the important aspect. The important aspect is that Sandra avoids the rock, which means that hopefully she's not going north anymore, but she's been able to change her direction. So theta will be tan inverse of 2 over 10. So let's hope this is some non-insignificant angle so that she can avoid this rock. And I'm getting 11 degrees here. Yeah, so hopefully that's a big enough angle. She doesn't hit the rock. So her new velocity, final statement, is 10 meters per second. So she's still going pretty fast. She was able to boost herself by approximately 0.2, but that 0.2 is not significant. And then north 11 degrees east. So that's the big 5, but with two-dimensional vector addition in there.